Hi, and welcome to Practical Game Development Examples. This day I will be talking about vectors. Vectors are really handy for positioning, calculating distances, angles, and moving stuff around. You can easily add, subtract, and do all kind of stuff with vectors. And pretty much each game development framework or engine already has vectors built into its boilerplate, and they're already ready to use. I will be using libggx to show you, but it should actually apply to each other engine or framework. So usually when you instantiate a vector, you do something like this. I have the velocity. We will be talking about that a little bit later. But you would say new vector and give it like a coordinate. But actually, a vector is more than a coordinate. It actually has a distance as well. I can show you that in this Photoshop sheet. So imagine this is the player, or this is a vector, and it's on 1.1. We could imagine that 0.0 would be the origin of this vector. So we could actually draw a line like here, and this line would actually represent the vector itself. So as you can see, a line has a distance, but it also has an angle, and depending on the framework or engine you're working on, it might calculate the angle from that line, or it might calculate the angle from that line. It kind of depends. Maybe it's even calculating it from here. So you have to figure that out for yourself. But as you can see, you can get an angle. So if you would get a vector, let's imagine again this is the player, that blue dot, and this is an enemy, and we want to shoot it. But we first want to know the distance between these two entities, so we can check. We can do a statement on the distance, or maybe you want to get the angle. And all that kind of stuff. So we actually want to create a vector like this. So if you have this vector, we have a distance. We have an angle as well, or maybe an angle from here, but that shouldn't matter. It's platform dependent. So how do we get this vector? That's very easy. We just have to subtract the target from the source. And that's basically everything you need to do, and that's already within your framework. You can easily subtract one vector from another. So I can show you this by a simple calculation. So let's do this for the x-axis first. This is the target, and this is our player, and you might want to shoot this, so we need that vector. So we have -2 here, and we want to subtract 1 from this. So that is 3. So on the x-axis we go 3 backwards, so -3. 1, 2, 3. Oh, actually I should maybe do it on a different layer and put it right here. So 1, 2, 3, and it's really that simple. So and now we have the y-axis from the target. Since we subtract the source from the target, we do 3 minus 1, and that ends up in +2. So we go 2 up. 1, 2, and let's make a nice purple line there that represents our vector. There, that's it. And now we can actually see that it corresponds between these two. So this purple line would be our vector, and we already know the distance. That's an attribute within the vector. We know the distance between these two targets. We know the angle, depending on on how your framework or engine calculates the angle from which axis it's calculating it. So yeah, maybe you want to move this player towards the target, and we can use this vector as well. It's just the vector is now currently um, let me say this correctly, -3 plus 2. So if we would increment our player position by -3 plus 2, you would instantly teleport right there. And that's usually not desirable unless you want to teleport or something in your game. But we actually want to increment this by our own speed. Maybe your player has a speed, maybe you want a predefined speed. That depends on you or how you want to implement it. But then we should actually have a normalized vector. It's called normalized because a normalized vector actually, if you would normalize this vector, it would actually cut it so it's exactly 1 long. So you can multiply it by your speed. So if you want to move 5 units within your game world, you would normalize, cut this vector and multiply it by 5, and then you would move 5, a distance of 5, exactly a distance of 5. Maybe it would be different on the y-axis than on the x-axis, because the vector is already there. If you would have a vector going straight up and you would normalize that, you would actually normalize it and you would actually cut it right there, because that's exactly 1. A vector that goes 45 degrees is actually 1.4 units long, so it would actually cut it about something like there. So that's a bit difficult, maybe a bit difficult to understand, but just bear with me. I'll show you a more practical example within libggx. So yeah, not really much is going on here. Let me walk you through this. Just creating a sprite bed to draw to the screen, a camera. I made a little raster. You can, like a grid. You can see the grid. Make these 0.0 lines there. Yeah, and I just made from the bed logic logo. I made like a player. Yeah, and in this case, I'm just calling it logo. You can actually set its center right in the middle here. And I'm also setting its origin to 5, 5, since that's exactly the center of our image, since we are drawing 10 by 10. So nothing's moving, really. Just drawing the raster and the logo, that's all. So we might want to shoot a bullet from this logo towards where we click, perhaps. So let's make a bullet class. This class isn't doing anything as well. It just instantiates a sprite. Whenever we call the constructor, it creates this sprite of 4 by 4. It sets its center to the source position, which we will give when we instantiate it. And we set the center as well, exactly to the middle of it. So it's actually, when we instantiate it, it would stand still. Yeah. So, like we said in this, all we need to do is subtract the target from the source. So we have a source position and a target position. Yeah, so let's do that. Let's first create a vector, and we will be creating this purple vector, and let's just call it between vector. Vector to between vector. That would be position, now target position, and we have to mind that we need to copy this, since if this target position would be a reference to another object position, a creature, then if we would not copy it, it would actually manipulate the position or the vector within the other object as well. So make sure you're copying it, or whenever you create this and instantiate this bullet class, make sure you copy it there, but it's always safer to do this in the constructor itself, so you are sure it will be done. So yeah, copy, and then we just subtract, and as you can see, these are all shorthanded, but each framework should already have this subtract, and you can just subtract another vector from this, and that would be the source position. Since we are subtracting from this, we don't have to copy our source position. So that would be our between vector, and this would actually already be that purple vector here, that purple line here. So what do we have now? I was just talking about normalization. So we have to make, we want to move the bullet a certain speed. We give it, when we instantiate the bullet, we give it a speed. And we always want to move the bullet each frame by that speed. So we need, however long our vector is, we always need a vector of 1. And I usually call that the direction, since it's the vector is 1 long, and it represents actually a direction. It's also a length, but it's always 1. So I usually call that direction. And all we need to do here is between vector, and if we do not want to manipulate between vector, we need to copy it, and then we normalize it. It's also built-in functionality within vectors. So that's all. So now we have a direction, and people usually call the velocity. That's the combined direction and speed. So we can actually multiply direction by the speed we give it, and we end up with a velocity, and we can simply add that velocity to the position of that bullet, and it will, if we do that each frame, it will already move in the correct direction. So we have velocity here. Velocity. So what do we actually do? Velocity equals direction dot. Oh, we don't want to. We might want to keep direction just as is. So again, we need to copy this. Scale yeah, scale it by the speed. And that's everything. Getting a little bit distracted here, but that's okay. So yeah, this is actually all. It is 3 lines of code, but this could actually very easily go within 1 line of code. That makes it even more powerful, even more special. So all we need to do is actually here still, as you can see, we set the center of this bullet sprite on position X, based on the position we declare here. So all we need to do is position, and this time we don't want to copy, since we really want to manipulate position. You just want to add this velocity to that. So this class is actually already done just by using vectors. We just need to have some implementation of our touchdown. Already created that. Going over it very quickly because each framework and engine works a little bit different. But essentially, this is a listener method or an event listener. We get an X, we get a Y for the screen position. We put that in a vector. We use the camera to translate that vector to from screen coordinates to world coordinates. And then I'll say where we touch, that's our target. Our source would be that logo. Maybe it can be your player, maybe it is another creature, depends on you. And we should actually create a private bullet here, and we can now populate that bullet. Whenever we touch down on this touchdown event, bullet equals new bullet, and then we have to give this source position, target position, and speed. So target source, and well, let's start with .5. I think that should be okay. And then obviously we need to draw it, but only draw it, since we are doing it this way, it's still null, and you don't want to get a null pointer exception. If bullet is not null, then we draw it, or we update it. How did I call it? Yes, and we use that same patch. We are drawing everything with it. So whenever we click, oh, it goes the other way around. Well, that's special. At least you see it. It goes the other way around. I'm probably target position dot copy dot subtract source position. Yeah, we need to subtract the source position, I guess. Sorry, a little bit blackout, but this would be copy. We copy that first, and then we subtract the target position. And it starts on. Now it goes correctly, but it starts on my mouse. Copy position equals source position. Yeah, sorry, I was doing this actually correctly. I was already doubting myself here. I made an error here. We need to actually pass source first and target first. That was actually kind of stupid. And then we can actually shoot out these bullets or whatever you want to actually shoot out by just clicking the screen. And this is actually just 3 lines of code to calculate this velocity. And we just add this velocity and use to the position, and use our position to place or position our entity or whatever you want to place within your game world. So I just said this could actually easily go into 1 line. Well, we could get rid of that, we could get rid of that, we could get rid of that, and we just gonna manipulate our velocity. So the velocity would be the target position dot copy and subtract the source position. So we're actually doing the same right there, and we could actually normalize it right here. And since we are copying a target position, don't need to copy again. And we then multiply, scale it by the speed. Some frameworks use multiply. So this would actually be exactly these 3 lines. I'll just show you. Now, as you can see, it's exactly the same. So with just 1 line of code, you can calculate the direction and shoot your bullet. And if you give each of your entities or creatures or things you want to calculate the position of a vector, you can just get their vector, do some calculations with it, and shoot your bullet or move your player towards that position. Or so a vector also has a distance, so we could also make the bullet stop on that position, or even fade out or die there. You just need a couple of more variables. So we need to float maximum distance, so that would be the represent the distance it should travel before it's stopping. Float, we should keep track of a current distance, the distance it has currently traveled, and we should set that on 0. And I think that should be enough. Then here we can, wherever we click, we make that the maximum distance. So we say max distance equals, yeah, vectors also have a distance attribute. So if we do target position dot copy, and we could actually also go this other way around, because from the source position to the target position would be the same distance as the target position to the source position. Doesn't matter. Copy. We just subtract it again. Oh, I think we can just do it like this. Target position dot length. No, that is calculating the length. Distance. Yeah, calculating the distance. So this would actually be a little bit cheaper function, like that. So target position, distance, this represents distance. I'm always saying to people, you should actually name your variables, your methods, full length. It doesn't take any time. It makes it a lot clearer. I'm not sure why this vector class is using these strange shorthand descriptions, but they should actually not. So we know our max distance, our maximum distance now. I should actually, when I say that, I should actually say maximum distance, but max distance, I think that's good enough. So maximum distance, yeah. We know that, so we are gonna implement, since we are moving our sprite or bullet each frame by our speed, we just increment our current distance by our speed each frame, and then we just check if current distance is less than maximum distance. Then we should actually add that velocity to our position. So we should show about here, and there, and there, and there, and there. So yeah, that's pretty much how easy vectors go. I will show you guys one more practical example. Yeah, we're gonna make that logo, our player, if you can imagine that. Follow our mouse. So it keeps following our mouse, and we can shoot bullets from it. Because as you can see, if you just put 50 here and -30 there, our logo would be actually on a different position, but it would still shoot from there. Because here we are saying the source comes from the logo, and then we give the source to that bullet class whenever we instantiate a bullet. So yeah, you're gonna make a new video about it, but I'm probably gonna cut it or paste it right behind this one. So give me a second. Ta-da! Change my pullover. So yeah, I created a displayer class. It's actually just that logo, but now we are actually moving around. When we touch the screen, so when we touch, it's actually moving around. And when I press the right mouse button, I can actually shoot stuff as well. Shoot little babies out of this angry looking smiley. So yeah, this isn't all that hard. You can see here I just have the player sprite. I just have the vector to position of the player. I keep setting this to the center, and I have a speed. I increase the speed of the bullets a little bit, so they travel actually faster than the player itself. When we instantiate the player, nothing really special is happening. I'm setting the position. And same as with the logo, I'm just giving it the bad logic image. Setting it to size 10 by 10, set its origin in the center of its size, and set its center to the position. We set that for now on 0.0. I have a public getter for the position. We'll go over that a little bit later. Yeah, so what's happening here? Whenever we touch the screen, this is going to run. I call this a vector to cursor, but this also can actually go in one line. All these three, actually all these four probably. So what's happening there? It's also basically the same as we had here in our touchdown event. We check the touch, we make the touch hold the screen coordinates, we unproject it so we have the world coordinates, and then we basically subtract the touch, which is the target, from the source, which is the position of this player. So the position vector in this class, in this object. So basically the same to get that purple vector again between the player and the target. So that's basically all this is doing, and we return that. And then we simply set the rotation. Since that vector has an angle to it, we can simply set the rotation of the sprite to that to the angle of the vector. And we add that normalized and the vector we just got, we normalize that and we scale that by our speed, which is a fixed number, a final float. Could be anything. If you wanted a variable speed, you can put it in there. So that doesn't really matter. Yeah, and we do actually the same as with the bullet. We just set it we increment the position of not the bullet this time, the player, and by that velocity. So actually I'm doing here the velocity. We don't have a variable for that in our main object. And we set it center to the position we just incremented whenever we touch the screen. And that's actually everything. So now I already can touch the screen with the left mouse button, and with the right mouse button I can actually shoot these little baby sprites out of my character. And of course, if you would just add a rectangle or something for collision detection around this, you can actually shoot an enemy, and whenever it collides you can hurt the enemy or kill it instantly. So this is really all the code I have to move around and to shoot stuff out of this sprite. So you can actually add. Sorry for that. Touch my microphone. You can actually add a health variable and let it shoot other stuff till it's out of health, and let it disappear or explode. But that's all outside the scope of this tutorial. This practical example is about vectors, and I think that will conclude it as well. So I hope you guys like this, and I will be making more of these small tutorials about specific game development related stuff, and with some examples as well. So see you guys.